Yeah. Good evening, everyone. Switch on a cam. Let's start off. Chalo, are those cams on? Where are the rest? Great. So let's start off with a new chapter, central mass collisions and momentum. This, is the linking chapter between till now whatever we did and the next chapter that we're going to do, rotational mechanics. The thing about central mass, till now we never bothered about the dimensions of the body. For example, if I said there was a incline and if I keep a block here, let's say if I keep a block here, mass m, or if I keep the block here, mass m, do you really think they'll go the same way? Isn't it? But in the second case, what would happen? This thing would actually start rolling, isn't it? Falls, topples, and does everything. We never bother to do, consider any of these cases. We always treated, no matter how big the body is or what shape it is, it's always as a point particle, and then we solve it from there. Right? Let me just remove the people whose cams are not on, and then we can continue. Yeah. So how do we decide what happens? Is first of all, you need to define something called translational rotational motion. So let's start from there. So what is center of mass? We'll simply call this COM. So center of mass it's a point about which motion can be split into translational and rotational motion. So before going into ahead, we need to define something like, first of all, what is this translation motion? Where are the rest? Now see. Anyone, what do you think is translation motion? So till now, what you studied, right? The straight line and all, that's not translation motion. So how do we define translation motion? If all points on the body move in equal, parallel paths, the body is said to be in translation. Meaning, for example, let's say if you take a block like this, so when the block has gone from here to here, if you call this is point A, so this is this. If this is B, it goes like this. If this is C, it goes like this. So if you see, all the paths were equal and parallel. But you could have done something like this also. We have a rod like this. And this rod is taken like this. You're getting? I didn't write something like this. So if you see here also, right, the paths are equal. So if you take any 3 points or any number of points on the rod, you'll observe all the paths are equal and parallel. You can see the motion is always in, the motion of the points is always equal and parallel. So a body can go even in a curved motion and still it can be called as a translation motion. Adrit, I can't see you, right? Your screen was blank. Just give me a sec, let me take attendance. Who is missing? Someone is definitely missing. Okay, yeah, Adrit, your camera is blank. Malika, your camera is not working. So your cam, yeah, there. These people now, where did this go? Just give me a minute. I'm just calling up. Sure. So when you say translation motion, right? It is like, if all the points on the body move in equal parallel paths, we say the body is translation. Then what's rotation? So if every point on the body rotates about the same angle, now don't get confused between rotational motion and circular motion. I'll tell you the difference. Both are not the same. So if you got a rod like this, and if this rod is rotating, so this point is like this. If you see, all cover same angles, they don't cover same distances. So this is how we define something called translation and rotational motion. Clear with this? Great. So let me take an example, and I think you'll understand that is better. So understand one thing: rotational motion, translation motion, right? This is completely different from what you have studied till now. Example: let's say you have a case like this. So let's say we got a rod here, and this is like a pendulum here, and this is fixed here. So this block here is welded. A, B, C, D. Correct? This is like a fixed thing here. Case 2. This is hinged here. You're getting it? This is a hinge. It's not welded. Hinged meaning it is free to rotate about that point. Think of like this. Ever seen this, giant wheel में cabin? If you're sitting in a giant wheel, do you observe how the cabin ka wheel looks like? It's kind of just like hanging. Think of like this. For example, if you look at the pen in my hand on my screen, if you can see, right? Now, no matter how much I rotate, if you see, this orientation is always up and down only, isn't it? The cap this is always pointing up and this is always coming down. If you see, this is called as hinged. But if this was welded, this should have seen like this thing. It would look like this, inverted. You're getting? If it was welded, it would go like this, no? But if it was hinged like this, maybe if I can take something more heavier, think like this thing. See, if you look at this bottle here, if this was hinged, meaning it was free to rotate like this is what I mean by hinged. So if I rotate this, what will happen? This is see how it looks. No matter how much I rotate, the bottle is always vertical. But if it is welded here, when you rotate the bottle, it becomes like this. Getting the difference? So that's the difference between the welding and the hinged. So this is like a cabin on a giant wheel. So now you tell me, which case is translation, which case is rotation? Is the question clear? We have a block ABCD fixed. In the first case, it is welded. In the second case, it is hinged at the center. Which case? Is welded, and which case is translation, which case is rotation? Okay, someone says first is translation, second is rotation. Okay. First is translation, second is rotation. Let's see. Now, let me show you this. Lakshika, are you there? Switch on your cam. So look at this first case here. So I'll just brief it up, listen fast. I think they forgot to add you in the group. So what is this center of mass thing? So this is how we define it. This is the point about which, the motion can be split into translation and rotation. So currently we are discussing like what is translation and what is rotation. So translation and rotation are not like what you studied till now. Translation and rotation, right? This is how we define it. If all points on the body move in equal parallel paths, we say the body is in translation. So you can even go in some random curve. The only condition is you should have equal and parallel paths. In rotation, you should cover same angles. They don't need not travel same distances, but the angle covered should be same. So that's the definition of translation, equal parallel paths. Rotation is same angles. So here we are taking an example here. So in this case one, we have a block here which is welded. In the case two, it is hinged. So look at the first example. Do keep your cams on. Case one. So if I rotate this 90 degrees, can you tell me what will be the orientation? If this was A, B, C, D, which one is A, B, C, D here? What is this?
B.
That is B, C, D, and A. So if you try to plot this, look at this thing. B has gone like this. A has gone like this. C has gone like this. D is gone like this. Does this look like equal parallel paths? But they all cover same angle, isn't it? If you actually see here clearly, OA and OD ka circle is bigger than OA ka circle. D covers more distance than this thing. So if you see in this case, all of them are traveling same angle here. So if I just use another color here. They cover same angle. This is pure rotation. Case two, where this block is free to move, that is hinged at the center. And do adjust your cam so that your face is completely visible. Lakshika, you need to adjust your cam a bit. Please keep these things in mind every time. I can't repeat in the class. So if this was hinged, and if I rotate this by 90 degrees, now how will the orientation be? If this was A, B, C, D, what was this? This is also will be A, B, C, D only, no? That is the meaning of a hinge. It is always free to rotate about the center. It will always orient in the same way. So if you try to look at the paths here, this is A, this is B, this is C. Can you see? They are equal parallel paths. That is the meaning of a hinge. Think of like a cabin or cable car, in a giant wheel. It is free to oscillate. It's like a pendulum kind of thing. It is free to move there. These are equal parallel paths. So this motion is pure translation. So the important thing, you define translation and rotational motion for bodies. So in this above examples, if you see points A, B, C, D, all four of them go in circular motion. So you can say case one is circular motion plus rotational motion. Case two is circular motion plus translation motion. Are you getting the difference? Circular motion and rotational motion are not same. Rotation is defined for body. Circular motion is defined for particles, for points. So points A, B, C, D move in circular motion. Translational and rotational motion are defined for bodies. Body is nothing but collection of particles. Getting this thing? So that means till now, until work power energy, kinematics, loss of motion, friction, circular motion, every work power energy, we have never studied a body. What you have studied is always a particle. If I say a block of mass m is given, you always treated it to be a point particle and you studied that problem. We never studied bodies till now. We never cared about rotation. I hope this thing is clear. What is translation? What is rotation? You don't define rotational motion for particles. Particles can go in circular motion or straight line motion or curved motion. But the moment you say translation motion, rotational motion, you're talking about bodies. You're not talking about particles anymore. I hope this was clear. So this is important. So most people have this feeling like rotational motion, circular motion, don't same. They're not at all same. They're completely something else. Meaning this is the best example. So this was a pure rotation where particles are going in circular motion. This is pure translation where particles going in circular motion. Clear with this example, everyone? I hope everyone understood what is translation and what is rotation. Great. Next thing. I can even have more combinations of it. Example, if we have a rotating wheel or rolling wheel, what kind of motion is this? If you have a wheel rolling on the floor, this can be split into two parts. You can take pure translation, meaning as if the entire body is simply translating. And just a translation, and this is a rotation about the center. So a rolling wheel can be studied by splitting the motion into two parts. In this case, there's no circular motion. How are these points going? If you look at the path of this point here, it is going like this. No? This is not a circular motion. That's a cycloid. So in this, particles are not going in circle. This is a combination of translation plus rotational motion. What about this thing? If you have a table fan which is swinging, and this diagram. So let's say you have a fan like this. It's not looking good, but yeah. So let's say we have a fan here which is swinging, a swinging table fan. Or you can say table fan on swing mode, basically. So if you look at this fan is rotating about this axis. And this whole setup is also rotating about this axis. This can be split into two parts. So rotation about its own axis, a rotation about this thing. So it's a rotation plus rotation. You can have combinations like double rotations. Every time you need not have translation plus rotation only. You can have anything. Have a look at this.
So I understood the first column part, the blade rotating. What is the second rotation?
It is a table fan swinging, na?
Okay. Understood.
वो table fan swing होता है ना ऐसा.
हाँ, okay.
Please have a look at this.
In the fan, where exactly is the force applied to make it rotate?
That motor takes care of it.
Achha.
For torque, you don't need a force. You'll use something called torque.
So even helicopter will be two only, right?
It depends. Helicopter exactly is what? It's like helicopter doesn't rotate, right? Helicopter ka blade rotates.
Okay.
You don't want to sit in a helicopter which is rotating. Next thing. So that is the basic idea about translation and rotation. So that's the first idea you should have. Getting it? So this is what. So this chapter connects between translation and rotation. So till now, what we have studied was only translation. You never studied rotation. Circular motion is not rotation. So be careful with that. Okay? Now, if you take a body and throw it into the air, we observe a certain point goes in a parabolic path. Basically, it goes in a projectile motion. Meaning everyone else is just rotating and going and everything, but there is this one particle which behaves as if it's like a particle on point, and the remaining points rotate about this. Rotate about this point. So this point is called center of mass. So if you take, for example, consider a rod and if you throw it into the air, you will observe when you throw this rod into the air, the center of the rod will follow a parabolic path. And when as the rod is rotating, this is what you'll observe. So this point A here, you're getting it. So this is how the rotation is happening. So when you throw a rod into there, this is what you'll observe. There is one point on the rod which will go as if it's like a particle. It behaves like a projectile motion. And it looks like everything else is rotating about that point. So here the center C behaves like a projectile. So till now in kinematics, whenever we studied a body is thrown into the air, a block is thrown into the air, the projectile motion didn't happen for all the particles. If you look at the motion of A here, it looks very complex. If you look at the path of A, it would this is how it would look. We don't know how to study this. This is the path of A. The point A is going in a circle, whereas the center itself is going in some kind of, so you have one parabola plus a circular motion here. It's very complex to study. Screwdriver will not be nothing. Screwdriver is nothing. So here, if you see C is the center of mass here. The motion of C represents the translation motion here. So whenever you throw something into the air, right, when you say it is going in a parabola projectile motion, the entire body is not going in a projectile parabolic motion. There's only one point on the body which is actually going in a projectile. So here C is the center of mass, which behaves like a projectile. Every other point on the body is going in some weird path. That's the first thing you need to understand. Till now, whatever we studied in till work power energy, you treated everything as a point particle and you studied. You never cared about the size of the body. You never cared about the dimensions of the body. Is this clear? So this always works. Meaning, if you take a body and you throw it, you'll always find a point which will actually take the part of a trajectory parabolic path, and everything else will rotate about it. This is how it would kind of look. So bad. See. So these people, what they're doing, right? They're taking some random objects, throwing into there. Look at the first one. This is your badminton racket. You can see that shape, right? A ring with a rod kind of thing. Then you took something kind of like a ball with a rod kind of thing. Look at that shape again. Some weird shape. Then they took a disc. Now what they did for these bodies, right? They painted that center of mass with some orange paint and they're throwing into the dart. This is the same, tennis racket which that wrote in the beginning. So that blue color spot, that orange color thing you can see is the center of mass. Just look at that path. Can you see a parabola? Did you see the parabola there? It throws again, see. That's a parabola. I hope you can see the parabola clearly there. But if you actually look at the motion when they throwed it initially, this was that. This is the same tennis racket. See how it was going? It is rotating, it is going, it is doing all weird things. But there is one point on the tennis racket which is following a parabolic path. So that would be the center of mass. That's your parabola. Now this is that second shape, the ball and the rod kind of thing. You take any weird shape, you mark the center of mass, you'll always find a path. This is the disc. It's wobbling a bit, but there you can see it. Clear? So what I said just now is not my imagination. This is true. So whenever you throw a body into there, you'll always find there's one point on the body which goes in a parabolic path. But there's one point which goes in a parabolic path and everything else rotates about it. Is this concept clear? This idea is quite useful because when you do the next chapter, rotational mechanics, that's where we're going to use this. Let's see a question based on this. There, so I taught you only one thing. About center of mass will go in a parabolic path and everything else will rotate about it. So let's say we have a rod. This is the origin. This is point A, which is L by 2, comma 0. And this is point B, which is minus L by 2, comma 0. So someone projected this rod with speed U, angle theta, and at the same time, you throw the rod with some rotation also, omega. And this thing flies in a parabolic path, and the rod becomes something like this. So the rod is rotating also and going also. Gravity is there. A rod is thrown with speed U, angle theta. Find the coordinates of A as function of time t. So you throwed a rod with rotation and translation, meaning you projected it also with the angular velocity omega. Find the coordinates of point A as function of time t. Here C is the center of mass. Let's get this. Is the question clear? So that center will follow a parabolic path and everything else will rotate about it. So there we have a parabolic motion plus a circular motion. Let's get this. Try. Again, I didn't teach you anything. I just taught you only one thing. If you throw something into there, center will go in a parabolic motion, kinematics, and it goes in a circular motion. Let's see. Okay, let's see. Try others. I'll give you a minute more for everyone. Hope everyone has seen your groups. There's a PTM tomorrow and Saturday. So do try to attend on your respective timings. Just a general thing, nothing important. Utsan, you need not attend. Like you want, you can come there, but I have nothing to say about you. So next time we can talk about you. This week is packed with PTMs only. Today it is your seniors. Your seniors to literally have every month now. Syllabus got over now. They need more PTMs. Today they're going to get encouraged a lot today. Let's see how to do this thing. What you do first thing, the center goes in a parabolic path. So let's find the trajectory of the center of this point C here. So let's set some point here. Into with parabola. Let the rod be here. Again, the rod could have been anything, doesn't matter. I'm just showing like this. I'm exaggerating the figure a bit. So this is point C. So what are the coordinates of C first of all? X coordinate of C will be u cos theta into time, projectile motion. Y coordinate of C will be u sin theta into time. You should know this thing. In case you forgot, you should go and definitely revise the kinematics notes of GT square. There, I got this thing. And let's say from this position, this thing is rotated by an angle theta. So this is point A. What is theta? Theta is omega into time. Remember circular motion, angular velocity into time is theta. So let this rotate by theta. You can tell me, sir, how do you know it rotates like this? Why can't it be obtuse angle? The theta sign takes care of it. If it is up to you, the sign takes care of it. You don't worry about that. So from here, if you drop this length is L by 2. So this vertical height will be L by 2 sine theta. And this horizontal distance will be L by 2 cos theta. That means from point C, whose coordinates are xc, yc, you're traveling. So xa would be xc plus extra distance L by 2 cos theta. That is u cos theta t plus L by 2. I'll do one thing, but I did a mistake. Take it as alpha. Because theta is already there, no? It will be confusing. L by 2 sine alpha, L by 2 cos alpha. L by 2 cos omega t. Similarly, y coordinate of A would be yc plus L by 2 sine alpha. If it has rotated an obtuse angle, automatically you'll get a minus sign, so you don't worry about this. U sine theta t minus half gt square. This is how center of mass is useful. You can split the motion into a projectile motion plus a circular motion and you can solve. Play with the coordinates. Check it out. Clear? Turn in the page. So great. So that is the main idea of the center of mass. So what does the center of mass exactly do then? Locating center of mass. So if you have particles M1, M2, Mn, R1 bar, R2 bar, Rn bar, so on. For particles, the center of mass formula becomes R center of mass is sigma mi Ri by sigma mi. I'll write it down once. M1 R1 bar plus M2 R2 bar, so on till Mn Rn bar by M1 plus M2 plus so on till Mn. So R center of mass will be sigma mi Ri by sigma mi. So if you put delta on both sides, the change in center of mass position, delta RCOM will be sigma mi delta Ri. So change in position of each one. This will be quite a useful result. We are going to use this later on. That's your R center of mass of particles. So if you want for x coordinate, then just take only the x coordinate, sigma mi xi by sigma mi. If you want for y center of mass, sigma mi yi by sigma mi. Z center of mass, sigma mi zi by sigma mi. This is what you use for particles. This chapter, right, is very important for the second reason, actually. This is the first chapter where we are going to use calculus or integration, right, for elements. Meaning till now we used integration, but remember calculus mein humne kiya tha how to find area of a disk by choosing elements, cutting and all. This is the first time you will see, like, where we are going to use it extensively, and that we are going to use it for rotational mechanics, fluid mechanics, gravitation, electrostatics, magnetism. It will literally repeat for another 6-7 chapters. And if you take for continuous bodies, what are continuous bodies? Anything, matlab, lots of particles, spheres, the disk, ring, anything. the formula becomes x center of mass will be integral x dm by integral dm. What is this x here? This is the x coordinate of the dm particle. So on a system, if you take a small piece dm, it is the x coordinate of that one. The y center of mass will be integral y dm by integral dm. So use this integration when you're talking about continuous bodies. Use the first formulas for particles. We're going to see both today anyways. Integral dm. Have a look at this. Here r bar is your position vector in case you're confused. R1 is x1 I cap, y1 j cap, and z1 k cap. Clear? Any doubts on this page? Any confusion so far? Please ask me. Aryan, Swastika, clear so far? Ali? Udayan? Clear now? Going ahead. Let's see a question. Like I said, don't worry too much about the notes. You'll get the PDF anyway. So let's focus more on thinking, understanding, and everything. I know my handwriting is not great, but do manage with it. Anyway, you're not going to what you're going to do with beautiful handwriting. So let's say we have a cube. Most people come and ask me, sir, physics ka revision kaisa karna hai? I said, take out 20 problems and start solving. Should I make a formula sheet for physics? I said, bullshit. What formula sheet will make? Just think about it. Kinematics. Kya formula sheet will you make? You'll write three equations. A is dv by dt, v dv by dr. V is equal to dr by dt. And the three equations. Bas ho gaya. Of what formula more will you write? Tell me one thing. How will you do a problem like this by revising? Matlab, if you want to revise the theory, what is the theory? When you throw a particle into there, center of mass will go in a parabolic path and load it in a circle. Bas ho gaya na concept. Do this problem. This is what I'm saying. It is like, watching YouTube channel and thinking you know how to cook. You really want to learn? Start solving problems. More problems. By problems, your theories will get cleared. So we have this thing here. This is your origin. So we have one particle here, mass m. We have one particle. I shouldn't have kept it there. I don't like that point. Let's see here. Let this be mass m. Let this be mass 2m. These two sides are equal. So midpoint of that. Here is 3m. Again, it's equal here. And here 4m. Here equal here. Find the center mass of the system. So there are four particles m, 2m, 3m, 4m on a cube of side A. Find center of mass. Remember what is the formula? This one, m1x1 plus m2x2 plus m3x3 by m1 plus m2 plus m3. Y coordinate is m1, y1, m2, y2, m3, y3, so on and so on. It is more about finding coordinates than actually solving the problem. Give it a try. Try, you got a minute. Just give it a try, get some water and come. Answers? Okay. The first thing is finding the coordinates. Okay, we have one answer. Lakshika got all the three coordinates. 4a by 5, 17 by 20. Numbers are bad. 9a by 10, I'm not sure. Let's see the answers. How to find coordinates? If you travel along x-axis, only the x-coordinate will change. If you travel along y-axis, only y-coordinate will change. So if you're traveling from this way to here, then this will be 0, 0, a. And then if you go up, then you're traveling along y-axis, so 0, a, a. If you travel this way, then you're traveling along x-axis, a by 2, a, a. Similarly, if you travel like this is a, 0, 0. Then if I go straight up, then this will be a, 0. And then this guy will be a, a by 2. And for 3m, if you go this way here, this will be a, 0, a. And 3m ka coordinates will be a, a by 2, a. Check your coordinates. Then x center of mass will be mass m. Uska x coordinate is 0. I'll write for one properly. For 2m, the x coordinate is a. For 3m, the x coordinate is a. For 4m, the x coordinate is a by 2 by total mass. Anyone didn't get the coordinates, or if I messed up, please let me know. That would be 2 plus 3 plus 2, 7, 7a by 10. That is the first one. I can do the same thing for this guy. This would be ma, 2ma, 3ma by 2, 4ma by 10m. M anyway cancels off, and this would be 1 plus 2, 3, 4, 7, 7 plus 1.5, 8.5 by 10.85 a, or you can simplify however you want. 17, yeah, 17 by 20 kuch aayega. And for this guy, z is how much? Yeah, it's okay. Then ये क्या होगा? ma, that is ma. Then 2ma by 2, 3ma, 4ma by 10m. 1 plus 1, 7, so 9ma, 9a by 10. Check. Lakshika, you got it right. Aryan, right. Z coordinate you messed up, I guess. Anika, you messed up the J by component. Neil, you messed up the Y also, Z also, X also. So see what went wrong. Do check everyone. Like I said, there's nothing in the question, only about finding coordinates. How to find the coordinates? You know where we did this first time? Anyone remember? Vectors. Finding position vector. Clear, na? Palaksh, Utsav, got this? Rehan, Vidyut, clear. Swastika, got this? Next one. This is not exactly a question, a theory also, but let's do this. It is important. This is one of the very important statement. So let's say we have a square. M here, 2m, 3m, and 4m. There are 4 particles here, A, B, C, and D. Find the center of mass of A and B So just treat A and B as one system, find the center of mass, find center of mass of C and D, then find center of mass of AB and CD system. What I want you to do is find iska center of mass, you'll get something. Find iska center of mass, you'll get something. And these two ka center of mass, we get something. And we will prove this will be the center of mass, all four of them. Which I know looks obvious, but we need to prove it. So if you can divide a system into multiple pieces, and if you find center of mass of each piece, and then if you find the center of mass of those center of masses, you get the center of mass of the whole system. I know it looks a little weird to explain, but I'll write it down. But I hope you got the point there. Find this center of mass, find this center of mass. You get two center of masses. So when you find the center of mass of these two center of masses, jo aayega, that will be the center of mass of ABCD. So even though it kind of looks obvious, quite a powerful statement. Yeah, try. You got a minute for this. Not tough. Finish off everyone. The test is deadline till tomorrow night. Hope we're giving it. Kya tha ye week ka test? Ray optics, no? It's a mains level paper, easy one it is. Next week you have a full combination. Kinematics, NLM, friction, circular motion, work power, energy. And then again after that we'll have one more ray optics test we should write. Actually, we didn't write enough. After that, what is the schedule? You have ray optics and center of mass. That is a little far. Chalo dekhte hain. Hope everyone tried the ray optics ka advanced sheet which I sent you. Start working on that. It has good, pretty good detailed solutions also. I think if you can finish all that, most of the things will get cleared. Let's look at this guy. So if we take AB ka center of mass, X center of mass will be 2A by 3. Y center of mass will be 0. If you take CD, X center of mass will be 4M0, 3MA, 3A by 7. Y center of mass will be A. So now what I am suggesting is replace this entire AB with a particle here of 3M at 2A by 3, 0. Replace this entire particle with a mass 7M at 3A by 7, ZA. And now when you try to find the center of mass of these two, we get it somewhere. This will be the center of mass of A, B, and C, D. So X center of mass of A, B, C, D is 3M into 2A by 3 plus 7M into 3A by 7. So you can do this actually. You can even you can replace the entire system with a 3M particle, and you can treat that as a new particle and solve the problem. This would be A by 2. Y center of mass ABCD will be 3M into 0, 7M into A by 10M. If you actually try to find for all four of them, you get the same answer. Making sense? So this will be our first property that we can put it down. Clear? So let's see. So what this thing says is, if a system is divided into n parts. So a bit of a theoretical statement, so listen carefully. if a system is divided into n parts, the center of mass of the n parts is the center of mass of the system. I know it looks a little repetitive. What it says is, suppose if you have, let's say, lots of particles, and you divided this into one system, second system, third system, fourth system, fifth, so on. So all these guys will have their own center of masses, C1, C2, C3, C4, and Cn, and so on. So what this statement says, so if you treat these guys itself as a, so C1, C2, C3, and Cn, and so on. And if you try to find the centromost of all these things, this will be the center of mass. This is the center of mass of all the C1, C2, C3, and Cn. And I'm saying this will be the same of all the particles. You might be, now, what is the use of this actually? The use of this is, later on, for example, let's say I have to find a center of mass of a system like this, a cone plus a hemisphere, an inverted ice cream cone. Now, if you ask me to find the center of mass, I don't know what to do. But I know the center of mass of the cone. I know the center of mass of the hemisphere. So I can treat this system, the entire cone as one particle, C1. I know the center of mass of the entire hemisphere as one particle. And the center of mass of C1, C2 will be the center of mass of this weird shape. Center of mass of C1 and C2 will be COM of that shape. Is this making sense? This is what the statement is saying. If I give you some random amoeba shape, I don't know what to do, but if I can somehow divide that amoeba shape into something which I know, then the center mass of the things which I know will be the center mass of that random shape. Now, is it making sense? You understood why the statement is so powerful? There was a question in JE once, they asked something like this. They said there's a circle, there is a particle, there's a vertical rod, and there's a horizontal rod. And they said find the center of mass. This was a question in JE. So this is what I mean to say. So you can actually find individual center masses and find for the whole system. Please have a look at the statement. Quite a powerful statement, even though it kind of looks obvious. C1 is the center of mass of cone. C2 is the center of mass of hemisphere. Any doubts on this? As such, center of mass calculation for particles is easy. There's nothing there except that sigma m1 r1 star. What we are more interested in is for the continuous bodies. Clear? Can I turn the page? Vidyut, go ahead. Palaksh, Neil. Palaksh. Clear? Going ahead. So we can also say COM is a point about which we can assume the entire mass is total mass is acting. Again, this is only for problem's sake, okay? That is, while drawing free body diagram, the mg vector passes through center of mass. That's it. That is the meaning of it. While drawing weight vector, or draw weight vector from, drawing weight vector, that is, draw mg vector or weight vector from center of mass. Whereas in reality, the weight is acting actually at every point. More than center of mass, there is actually one more thing called center of gravity. This is actually more powerful, but we don't have in the portion. Later on, maybe in gravitational, we will see one or two models there. So center of gravity is a point about which the net force acts. So if the gravity is uniform, means if you keep a body in a uniform gravity, center of mass and center of gravity both are same. The meaning, let's say if you take a very tall building, the lower floors that experience more gravitational force compared to the floors on the top. There's a very small change, but yeah, it is there. So lower floors experience more force. So to take that into account, if you look at this, the center of mass is like a geometric center. This will be the center of mass. So basically, this is a geometric center. Whereas in reality, the entire force, center of gravity will be slightly down. Center of gravity, this is slightly, COG is lower. So center of gravity is a point where the net force acts. In uniform gravity, what happens if the force is same everywhere? Then it doesn't matter. Normally on Earth, right? Even if you take a 1 kilometer building, gravity really doesn't change much. So it doesn't really matter. So center of gravity, use it for very tall, buildings or whenever the gravity changes. So just keep that in mind. So right now in this chapter, we will not be dealing with it, but gravitation we will see. So use center of gravity when G changes. Formula has come something like this thing. Our center of gravity will be R df by integral df. ऐसा कुछ आएगा. I'll teach you this thing again in gravitation. We will do one problem. But there is something called center of gravity. So if you ask me, say, among center of mass and center of gravity, theoretically, which is more stronger, center of gravity makes more sense. Difficult to study, but clear with this switch. Next thing. There need not be mass at center of mass, and center of mass need not be on the body. We keep saying, all the mass is located there, all the mass is located there. There need not be mass only. For example, if you take a ring here, or if you take something like this, a boomerang, the center of mass is outside. There's no mass at center of mass. It is not even on the body. There's no mass at the center of mass of a ring. So if you actually try to touch there, there's nothing there. So only for problem solving, right? If you take a ring, you can assume mass is acting from there for problem solving sake. COM always lies on line of symmetry. What's the line of symmetry? When you say line of symmetry, about that line, the either side of the line should look identical. I'll show you. If there are two lines of symmetry, it will lie on the point of intersection. This will be quite useful to figure out, center of mass at least for one coordinate. It will lie on intersection. So if you take something like an arc disk, or let's say if you take something like a rectangle, or let's say even if you take this boomerang shape, this is the line of symmetry. Meaning the left and right will look symmetrical, identical. So the center of mass should lie somewhere on this line, but I don't know where. If you take a rectangle, this is a line of symmetry. This is also a line of symmetry. So this should be the center of mass. For this boomerang, this is the line of symmetry. It should be somewhere on that line, but I don't know where. COM always lies within the extreme boundaries of the particles. What do you mean by extreme boundaries? For example, if there are particles like this, extreme boundaries meaning draw the extreme particles. This is your extreme boundary. The center of mass has to lie within this boundary here. Same thing, if you take this boomerang also, if you take the extreme points, and if you join them, this is the extreme boundary. Center of mass need not lie on the body, but it has to lie within the extreme boundary. If you have a system, join the extremmost particles, and if you make a whatever shape, it is closed figure, you will find the center of mass should always lie within that. Please have a look at this page. These are the kind of questions you get in more than one choice. They'll ask you some statements and ask which of the following is right. Clear? Can I go ahead? Abhinav, Aditya, clear so far?
Yes.
Next one. The center of mass of a triangular plate uniform triangular plate. Is it the centroid? It doesn't matter. You can take even a scalene triangle. Centroid is the center of mass. This I forgot to write in the beginning. For a two-particle system, center of mass always lies between them and along the line joining them. So if you take two particles A and B, you can be sure no matter what is the mass, center of mass should definitely lie on the line in between them. When a body is suspended by a thread, line joining center of mass and the point of suspension is always vertical. This is quite a useful thing to find center of mass of any random shape. Meaning, if you take some random amoeba shape here, and if you have tied this with a rope, you will observe this is the point of suspension, the center of mass, and this thing will definitely lie on the line. This is actually based on torque. We'll see this in rotation, but quite a useful thing. So if you have any random shape, first suspend it in one position, suspend it in another position, and draw two lines. Wherever the other lines meet, that is the center of mass. Meaning, if you take a shape like this, you can be sure the center of mass of this system will be somewhere here. Is that making sense? There, these are all the properties of center of mass.
So,
Arjun.
so in the thread thing, even if you push the body towards one side, it'll always be
It'll come back to this position again. It's a stable equilibrium basically.
okay. No, but like it'll always be on the line joining the COM and the point of suspension. That
Right.
okay.
Clear? So there, these are some of the theoretical points about center of mass. Okay. Take a break. Come back by 7 o'clock. We'll continue from here. So any doubts, anything so far you can ask me, or else take a break and come back by 7. You can keep your cam off. You can be in the meeting. Anything so far? Any queries so far you can ask me, or else come back by 7 o'clock. Any doubt so far? Chalo, I'll be back by 7 o'clock then. Sure, let's start off. Now, the important thing. So till now, what we did for these particles and stuff, what happens if you have a continuous body? The integration is actually easy. The headache is converting a verbal problem into integration. So listen carefully. I'll show you one, and then we will do more. So first thing we will take is a uniform rod. So we define few things here. Lambda is linear mass density. That is mass by length. Then we define something called sigma, which is surface density. So basically lambda will be in terms of kgs per meter. This will be mass by area. So this is for sheets, discs, all this kind of 2D shapes. In school, what you said is actually rho, volume density. So when you keep saying density, people are actually talking about rho. This is mass by volume. So be careful what kind of shape you're talking about. So you use lambda for rods and arcs, and use sigma for sheets and for this thing. Now, remember carefully, we have some basic shapes here. The main important thing, right? For every shape, there is a particular way of choosing an element. If you know that much, I think the integration part is taken care of. That is the same logic we keep using in every chapter. So whenever you see a rod, the element should be, the elements are small rods. So listen carefully. I'll show you one, then we will do more on this. So let's say we have a uniform rod here. I know the answer is center, but let's see how to get that from integration. X is equal to L. So the first problem we are facing is, at every point, we have different X coordinates. So if I try to use the formula M1 X1 plus M2 X2 by this thing, which one should I take exactly? So it is changing. So this is what we do. At a distance X, take a small piece dx. Now this dx is so small, you can assume it to be like a small particle whose coordinates are x comma 0. So we define dm. This is the mass of the dx piece. Which is lambda into dx. That is the meaning of lambda, na? Kg per meter. Mass per unit length into the length of the dx will give you the mass. Now applying the formula, x center of mass is integral x dm by integral dm. X dm is lambda dx. What about the limits? Try to understand the meaning of limits, okay? When I say x is equal to 0, means you're talking about this particle. When I say x is equal to L by 2, you're talking about the particle in the middle. X is equal to L, you're talking about particle on the edge. So when x goes from 0 to L, you're covering the entire rod. That is the meaning of taking limits by integral lambda dx. So what you're doing is your summation of all the particles from this thing from 0 to L. So this is lambda integral x dx from 0 to L by integral lambda x dx. 0 to L. Lambda will cancel off. This will be L square by 2 by L by 2. Kind of obvious. We know how to, the center was in the center. But this is how you actually integrate and get it. Now you guys try this. We have a rod here. X is equal to 0. X is equal to L. Lambda is lambda naught into x square. Find the center of mass. Lambda naught is some constant. Use this as a reference and solve this. Lambda is equal to lambda naught x square. Find the center of mass of the non-uniform rod. So, how is this rod? At 0, there is no mass. As you go right, the rod is becoming heavier, heavier, and heavier. This rod is becoming heavy as you go to the right side. So find the center of mass of this rod, whose density is lambda naught x square. There, this is the logic we have to use. The steps are same. What changes is this lambda. That is where the change happens. Try. I'll give you a minute and then I'll show you the next page. Yeah, get it. It's an easy one. X is equal to 0, x is equal to L. Lambda is lambda naught x square. Again, same story there. At a distance x, take a small piece dx. dm will be lambda dx, which is lambda naught x square dx. So x center of mass will be integral x dm by integral dm. Lambda naught will cancel. This will become L power 4 by 4 by L cube by 3. Easy. Check. How did you get L square by 2? Dimension not matching. This would be lambda naught integral x cube dx. So then you're not typing any answers. Others, you need to keep typing your answers. If you guys are not typing, I'll assume you're not solving. Right, wrong, I don't care. Do something. Is the steps clear? Swastika, got it? See where it went wrong. Any doubts on this? Anyone not clear with this? Please ask. Great. Next one. We have a rod like this. Theta by 2. Theta by 2. This is origin. This is x-axis. This rod ka length is 12. This rod ka length is L. Uniform rod. Bent into unequal V shape. Find center of mass. We have a rod like this of length 12 and a rod of length L bent into this thing. X-axis is the angle bisector. Find the center mass of this rod. Again, what is the logic here? Do I know the center of mass of this rod? Center. I know the center of mass of this rod. Center. Then you find the center of mass of these 2 points. No? Isn't that the story? Isn't that the property? If you give me some weird shape, I can divide that into something which I know. I will replace this entire upper rod with one particle here, the entire lower rod with one particle here, and I'll find the center of mass of these 2 particles. That will be the center of mass of this entire V shape. Is that making sense, everyone? Now try. I'll give you a minute more. That's why I said that property was quite important. Well. Now let me ask you one thing. How many of you took mass is same for both the rods? If you have done that, you goofed up. How can the mass be same? The upper rod will have 2m and the lower rod will have m. So hope you didn't do that mistake. So we can treat this as the center of mass. Let's take this as mass 2m. This length will be L, the center. And this coordinates will be L cos theta by 2, L sin theta by 2. The lower one, center of mass, will be here. Let's make this as mass m. This length is L by 2. So this will be L by 2 cos theta by 2 minus L by 2 sin theta by 2. Negative, na? So the x center of mass will be 2m L cos theta by 2 plus m L by 2 cos theta by 2 by total mass 3m. This would be mm will cancel. 2 plus half 5 by 6 L cos theta by 2. The y coordinate would be 2m L sin theta by 2 m into minus L by 2 sin theta by 2 by 3m. That would be 2 minus half to 3 by 2. That would be L by 2 for sin theta by 2. Check. 5 by 6 and L by 2. Right, Anika. Do check your answers, everyone. So the most common mistake, people take both the masses same. That is one thing you have to be careful, or else the question is really not that awesome. Yeah. Clear with this? I'll be expecting you guys will be able to handle the basic calculations. I'll be skipping steps while calculations. In case you didn't understand, please stop me and ask me. But I will assume you know. Matlab, is यहाँ पे देखो directly. I actually skipped this step and directly wrote the answer. I'll expect this much that you can do from here to here directly. That much calculations I'll start skipping now. You guys need to start learning that thing, how to skip steps. Clear with this? But still you got stuck, don't hesitate to ask me. It happens. Next one. Let's say you made a rod with 2 different rods. X is equal to 0. X is equal to L1. This is X is equal to minus L2. So this entire rod on the right hand side, cut density is lambda naught into X. This entire density on the left hand side, lambda is lambda naught X square. So you made a rod with 2 different densities. I'll give some different color shade. Okay, and length of the rods is also different. So find the condition between L1 and L2 so that the center of mass is at the origin. Meaning this rod ka center of mass and this rod ka center of mass should be at the center for these 2 things. Find a relation between L1 and L2 if center of mass of the system is at the origin. I hope the question was clear. So you made a rod with two different parts, L1 and L2, and both don't have same density. One has lambda naught x and one is lambda naught x square. Find the relation between L1 and L2 such that the center of mass will be at the x is equal to 0, the origin. Get this. Lambda is given, no? You can find the mass from there, isn't it? If I give you linear density. And don't worry about the dimensions. Dimensions won't match. That lambda naught has the dimensions to take care of it. So don't worry about that. Three is to 2. That is wrong. L1 square 9 by 8 L square. Nah, that is wrong. I'm not asking ratio. I'm asking relation between L1 and L2. Lambda नहीं लगेगा ना. That will be anyway gone. L2. Yeah, I think that looks right. You have one answer, everyone. So this is the idea here. I will replace this whole thing with one particle. Let's call it mass m1, and let this thing be x1, comma 0. I will replace this whole left side rod with m2 with minus x2, comma 0. And you're saying the center mass of these two, that is m1 x1 minus m2 x2, or let me write it as m2 minus x2 by m1 plus m2 should be 0. Agreed? So indirectly you're getting m1 x1 is equal to m2 x2. Now we know the formula x center of mass is integral x dm by integral dm. This, if you shift it, this is nothing but integral x dm by, this is total mass. That means m into x center of mass of any system is actually x into dm. Is that making sense? So indirectly, what we are doing here is integral x1 dm1 should be equal to integral x2 dm2. Is this clear? So what we did here, so at a distance x here, you took a small piece here, that was your dx1. On the left hand side, at a distance x2, you took a small piece here, that was your dx2. So dm1 is lambda 1 into dx1. That would be lambda 1 is lambda naught x1 into dx1. dm2 is the mass on the left hand side, lambda 2 into dx2, that is lambda naught x2 square dx2. Substitute here. This guy would be lambda naught x1 square dx1. x1 will go from 0 to L1. Lambda naught x2 cube dx2. This will go from 0 to L2. Integrate on both sides. This will be L1 cube by 3 is equal to L2 power 4 by 4. That's your answer. If this condition is satisfied, this thing goes off. This thing, if it's looking confusing, you can do like this also actually. You can split this into two parts. This will be lengthy. Mass m1, na? Find mass m1, integral integral dm. And then find center of mass x1 separately. Integral xdm by integral dm. Same thing, find m2 separately, integral dm, and find x center of mass separately, and then use m1, x1, m2, x2. Same answer aayega, but the steps will be little more. So here we have simplified that and finished it off. Basically, this is the idea here. Integral x1 dm1 is equal to x2 dm2. So on the left hand side, choose it as x2. This piece is dx2. On the right hand side, choose it as x1 and dx1. Check it out. I hope this logic was clear, right? By writing this way, right, your life actually becomes easy. There's no need to calculate x1 separately, m1 separately, or else you have to do 4 integrations. That would be quite lengthy. Finding the mass of each rod, finding the center mass of each rod, and then finding the center mass of these two. You could have done that. Hope you guys can handle this. Clear? Next one. Any doubts on this? Please ask. Again, I said, right, integration tough nahi hai. Did you see? Integration is only x power n and dx integration. Integration, you'll find it easy. The headache will be getting till here is the headache. And this, you will get used to it. Trust me one thing, it will be difficult now. So in case you're finding it like, sir, ye integration thoda confusing lag raha and all, it is quite common, part of the game. You will find it difficult, you'll find it weird. After 3-4 chapters, you'll still find it weird. By next year, you'll feel like, okay, meaning you'll get used to it. I think by the time the portion gets over, you'll feel like, chalo, this much I can handle now. That is how the transition goes. So don't expect, like, don't get into panic mode. You guys, some of you have a habit. Ek question nahi hai, to you start getting into panic mode as if the world has ended. Have patience. Learning takes time. All you can do is just keep your mouth shut and keep working. The reason why people mess up and don't get ranks is not because they don't have enough knowledge. That is because they can't assess the situation calmly and they don't take the right steps. The first thing they do is start panicking for no reason. Did you ever see when someone is drowning in a swimming pool, how does the diver save him? How does that swimming save him? First thing, they go into the swimming pool. They don't go to the person close by. They stay as far as possible. They catch their hair and they drag him. You know why? Suppose if you're drowning, let's say there's a pool here and you're drowning. And when this person is coming to catch you, the first thing, right, he'll not come close to you because in a panic, right, you will jump on this guy, you will catch him and you will grapple him. So you will sink, that guy also will sink, both of you will die. Because the only thing in your mind is I'm sinking, bachao, bachao, bachao. You don't care what the hell is happening. You jump on that guy first of all. So whoever gets close by, you'll catch him and you will drown them also. So in that scenario, what that person does, he slaps you. He beats you right and left so that you'll keep quiet and then he'll drag you out. So in case he doesn't want to slap you, first thing they don't come close. They'll be as far as possible. They'll try to just catch your air because once you catch the air and pull it, you can't do anything. You can just drag the person. It'll hurt a bit, but it is more safer option. So that way. It looks weird, but it happens because when you're doing, when you're panicking, right, you do nonsense things. 2 plus 2 becomes 7. That's the thing. I'm seeing with your seniors, they do dumb things. Next one. And especially when I keep a speed test for them, 90 questions in 1 hour, that puts a lot of pressure on them. You should see the kind of mistakes they do, some of them. There, we got a beautiful caterpillar. We have a caterpillar, mass M, length L. This is a uniform caterpillar. And it doesn't mean it will wear a uniform. It means the mass is uniformly distributed. Getting it? So you can treat this as a uniform rod. This caterpillar is going with speed u. So at t0, this is the scenario. After some time t, this caterpillar has started climbing the wall. Study well and go to IIT, you'll find a lot of them in the bathroom. So this is how the caterpillar started climbing the wall. Because all the heights are in forests now. So you'll find them. Caterpillar climbs the wall with a constant speed u. Find the position of center of mass as function of time t. Find center of mass, velocity of center of mass, acceleration of center of mass of the caterpillar. Let's get this. I hope the question was clear. We have a caterpillar of mass m level t0. It is about to climb the wall. After time t, it has climbed some part of the wall, and we will take time t will be less than L by u. Means some part is on the wall, some part is on the floor. If time exceeds L by u, what will happen? The entire caterpillar would have climbed, no? We don't want that situation. We want some part to be on the floor and some part to be on the wall. So find the center of mass, velocity of center of mass, and acceleration of center of mass. Let me write this thing: position vector of center of mass for the caterpillar for the time less than L by v. Get this, you got 3 minutes. Anyone confused with the question, please ask. You don't like caterpillars, ignorance all. When I was a kid, I think 5th or 6th standard, there were a lot of caterpillars near our house. We killed all of them. And then summer there were no butterflies. And then our school teacher taught us how does a butterfly is produced. Then we understood, shit, caterpillar becomes butterfly. We felt bad about it. Next year we didn't kill. How the hell will I know such a black ugly thing becomes a butterfly? Because summer that was the game, catching butterflies. See, we used to be so innocent. You give us one small tire, we used to play with the tire for full day and feel so happy about it. Now the kids bloody give them iPhone also, they don't care. Chalo, let's get this. Anyone not clear with the question, please ask. What is the catch? I'll give a small idea. Think of like this. End of the day, the caterpillar is uniform. You can treat this as one rod. You can treat this as one rod. And if you have two rods, what you do? Find the centromas of this rod, find centromas of this rod, and find the centromas of these 2 points, isn't it? So this whole question becomes like this. There's a rod here and there's a rod here. And you're finding the center of mass of these two centers. Try. That is the idea there. You just divide the caterpillar into two rods, one horizontal rod, one vertical rod, and solve the problem. The caterpillar and all that is just a story to confuse you. If I had simply said two rods like this, you would have solved it. L/4 God as a function of time पूछा. इतना अच्छा value कहाँ से आ रहा है तुझे? And why did you assume the rod is half and half? Okay, Neil got something. Anika, your dimensions not matching. U/T by L, U by L. I know what you did. You goofed up the mass. You assumed mass is same for both. That only then you get an answer, something of that sort. Try a minute more. So time t, this will climb how much? Ut. This will be how much then? L minus ut. So you can treat this thing as one vertical rod. So this center of mass will be 0, comma, ut by 2. And this mass, let it be m1, which is mass by length, total mass by total length into ut. This horizontal thing, the center of mass will be here, L minus ut by 2, comma 0. And you can assume the mass is m2, which is total mass by total length into length of this piece here, L minus ut. And you're trying to find the center of mass of these 2 points here. So x center of mass will be m1 is 0, that is gone. M2 m by L, L minus ut whole square by 2 by total mass m. L minus ut whole square by 12. Similarly, when you take y center of mass, m2 is gone. M1 will be m by L, ut into ut by 2, so u square t square by 2 by m. U square t square by 12. That's your x and y coordinate, everyone. So you want velocity? Differentiate dx by dt I cap, dy by dt j cap. So that would be 2 will cancel. L minus ut minus u, L minus ut by L. I cap. There I skipped a step there again. This would be u square t by L j cap. I use the chain rule. Chain rule name. What is that? Chain rule only. 2 times of L minus ut and then differentiate whatever is inside. This is your velocity of center of mass. You want acceleration? Differentiate velocity again. This would be q square by L I cap plus u square by L j cap. If you observe, the acceleration of center of mass is constant. Please check the steps. So the main catch here is when this thing is climbing the wall, mass also changes. Length is changing, mass is changing. So that's why you're getting a square cut term. Please look at the steps. So once you got x and y coordinates, it is just a matter of differentiation. Anyone not clear with this or not convinced with any particular step, please ask. So if they ask you find the net force acting on the caterpillar, it will be mass into acceleration. How then?
Can you explain how you got M1 and M2?
Mass total mass by total length into length of the piece, right?
Sir,
Total
you-
mass of the caterpillar by total length of the caterpillar into length of the caterpillar on the floor. यूनिटरी मेथड गॉड लेंथ एल के लिए मास एम एल माइनस यूटी के लिए कितना मास होगा बट गेट यूज्ड टू दीस थिंग्स total mass by total length into length of this thing na sure don't forget now that is very common thing that will come a lot of times net force would be this thing F is equal to ma Rehan clear with this sure no Vidyut Utsa got this Palaksh Arjun Aryan clear Swastika sure no Yasha Anika anyone not clear with this Anusha got this can I go ahead it's a good one so that is something about the rods so the next shape that we take is an arc
So
Arjun
on the previous one, we got acceleration constant. I know we assumed time less than whatever the L by U thing. But then shouldn't the acceleration also come as a function of time because eventually it'll become fully vertical, right?
in that case it will become zero no then once
That's
it becomes
right.
vertical there's no change in mass nothing it is just going with constant speed so it will be zero then
Achha, okay.
because see the whole this statement is valid only for time less than L by B
Got it.
What about an arc so listen carefully I'll show you how to do for an arc and then I'll give you something so this is the second shape it's a standard result you need to mug up the results though especially important for bits and mains so we have an arc lambda is the linear density R is the radius so whenever you see an arc this is how you choose elements like I said the main important thing is results and how do you choose elements the elements here are small arcs so this is how we choose so first can you tell me where will the center of mass be you can see there is a symmetry right it will be exactly on the perpendicular bisector this is a line of symmetry so that much so I can guess that the center of mass will lie on the vertical line so there's no need to find x coordinate so from the bisector at an angle alpha take a very thin slice d alpha again try to understand your job is to find this small piece here this length is rd alpha so mass of that small piece on the arc is lambda into length rd alpha And the coordinates of this piece will be, the x coordinate of this piece will be r sine alpha, comma r cos alpha. Means on the entire arc, you're dividing it into small pieces, and that small piece ka coordinates are r sine alpha and r cos alpha. At the center, alpha is 0. If you're exactly on the top, alpha will be 0. If you're on the right hand side, alpha is theta by 2. If you're going to the left hand side, alpha is minus theta by 2. The meaning of this is when alpha ka value changes from minus theta by 2 to plus theta by 2, you're covering the entire arc. Are you getting the meaning of these words? When alpha goes from minus theta by 2 to plus theta by 2, you're covering every small pieces on this. And that small piece ka mass is lambda rd alpha, and that small piece ka coordinates are r sine alpha and r cos alpha. Once you got this, x center of mass, you get back to the formula again. What is the formula? Integral x dm by integral dm. So here, x is the x coordinate of that small piece, which is r sine alpha, and d alpha is lambda r d alpha. So here, alpha is going from minus theta by 2 to theta by 2 by integral lambda r d alpha minus theta by 2 through theta by 2. Lambda r will cancel off, and this will end up with sine alpha d alpha minus theta by 2 theta by 2 integral d alpha. Now see, I know this should come to be 0. Huh? I'm just proving it to you. So this will be r sine alpha ka integration is minus cos alpha. Limits will go from minus theta by 2 to theta by 2. And this will be alpha. Limits will go from minus theta by 2 to theta by 2. So this will be r cos theta by 2 minus cos of minus theta by 2. And I hope you know cos minus theta is cos theta only. So this and this will cancel. You end up with 0. Like we expected, x center of mass is 0. It is on the line of symmetry. But I just wanted to show you the integration there. Same thing, if you do for the y coordinate now, y center of mass, integral y dm by integral dm. Y coordinate would be r cos alpha lambda r d alpha by integral lambda r d alpha, limits from minus theta by 2 to theta by 2. This much integration, right? You should be very comfortable. Right now, it might be a little difficult for you, but maybe after 6-7 months down the line, you see an integration like this, you should be able to put the steps directly. Advanced with this much integration, they expect you to be quite comfortable choosing elements and everything. You will get used to it, but it takes time. You need to do more and more models. And if you see, I'm really not using some hi-fi integrations here, basic sine cos integrations. But headache kiya tha getting that limits and all that stuff. Cos ka integration will be sine alpha, that will be 2r sine theta by 2 by theta. That's a pretty good result to remember. Please check the integrations once. Like we expected x is 0, y will not be 0. So whenever you take an arc, I'll just write the result in the next page and show you again. So if you have an arc, the center of mass will lie on the bisector. Coordinates will be 0, 2r sine, or I'll just write it like this, wait. From the center, this distance will be 2r sine theta by 2 by theta. The theta is this length here. If you take theta is equal to pi, this is the standard shape. This becomes a semicircle. The center of mass will be at a distance of 2r by pi. If you take theta is equal to pi by 2, it becomes a quarter circle. Remember, center of mass will always lie on the bisector. Bisector will be this. Don't take vertical line. Always say bisector. The center of mass will be somewhere here. This distance would be 2 root 2 r by pi. Interestingly, if you take in terms of coordinates, this guy would be 2r by pi, comma 2r by pi. That's where like this. It looks like semicircle ka result, but you have both x and y coordinates. Should be like 0, comma 2r by pi. Results are important. Definitely should mug it up. Exam, you won't have time to derive the whole thing. Look at the integration. Semicircle ka result is like a straightforward result they can expect. We did for an arc that is a more generalized result. Semicircle is standard. This arc ka result is fine. Do check out the integration. Any step you're not convinced, not clear, please ask. Like I said, the integration is actually easy. How did I take that small piece, RD alpha? How did I take the coordinates of that small piece? Was up important. I think if you understood this part, I think we are done. You did a good job. Integration हो जाएगा उसके बाद. So whenever you see this arc, meaning you should know like अरे बस ऐसा ही करना है. Meaning I'll just show you. Meaning it just won't stop here. This will just keep popping up everywhere. देखो. Same to same question रहेगा. We will see this in electrostatics में. There is an arc there, and the question is find the electric field and potential at the center. Now all this integration will look alien to you, but if you observe, the element is same. Did you see RD alpha, alpha? The way you choose elements will not change no matter which chapter it is. Uske baad, what happens that will depend on the chapter, but that part is easy to integrate again. So keep this in mind. So integrations are useful that way. Any chapter you see an arc, this is how you choose an element. And luckily physics में ऐसा सिर्फ 4-5 ही models है. So if you can remember that, you'll be able to handle most of them. Clear? Now let's see how they'll ask this question in the exam. ये तो standard result, तो I derived it for you. Let's see, you will derive. Next page here. Next class is more important. Right? Next class will be full of integrations. मतलब solid different shapes we take up. So don't miss the next class. Don't miss any class actually, but still. Clear? The 10 minutes break helped. People became fresh, had food. It helps. I just get extra 20 minutes only, but the 10 minutes ka break na will feel like again a new fresh class. We can get that speed back again. Last one for the day. Same question, but I gave you a semicircle because I'm a good person. But density becomes lambda not sine theta because I'm an evil person. There we have two of them. So we don't have a uniform density. So theta is measured from here. So we have a semicircle whose radius is r and the linear density is changing with theta. मतलब देखो क्या है? Sin theta is how much? Sin 0, 0. Mean there is no mass here. Sin 30, sin 60, sin 90, meaning the ring is becoming heavier and heavier as you go up. Then the ring is becoming lighter and lighter and lighter and lighter. Can you see how is that ring? As you go up, the mass becomes high and the mass decreases again. It's a non-uniform ring. Find the center of mass. Non-uniform semicircle. This is how they'll frame a question. So if you don't know how to choose elements, you'll get stuck here. Radius r, lambda naught is constant. Some random constant. Theta is the angle measured with the horizontal. Try. You know how to choose elements. Idea is this: whenever you see circle arc, take a small arc and mass calculate karo, limits ka, get the coordinates and finish it off. Is there any symmetry here? There is a symmetry. देखो ना, 0 to 90, 90 to 180, sin का value changes the same way. There is a line of symmetry. Sin 0, 0. Sin 180, 0. Sin 60, sin 120. Left and right are identical. This is the line of symmetry. Center of mass should be somewhere on the y coordinate. इतना तो पता है. So I won't calculate x. So I'll calculate only y. There is a line of symmetry for this. So that's what I was saying. The properties are important. If you know that, you can actually, after the integration, you can skip. Saves you time in the exam. Or options may you can actually see and finish it off. Right, Neil. Try, everyone. 2 minutes. Hmm. This is your line of symmetry. So we get sin 0. Let's say somewhere here sin 60. Sin 120, sin 180, the values will look same. Therefore, x center of mass is 0. Matlab, I just removed all the integration with this one statement. That's why knowing statements is important. Or else you'll calculate x. You will calculate, you'll get the answer though. But next thing. At an angle theta, take a small piece d theta. This is your arc RD theta. So this coordinate would be r cos theta, comma r sin theta. Mass of this small piece will be lambda RD theta. And lambda is lambda naught r sin theta d theta. You're interested only in the y coordinate. You know everything. And remember, theta ka value will go from 0 to 180. So integral y dm by integral dm. So y would be r sin theta. Dm would be lambda naught r sin theta d theta. 0 to pi by integral lambda naught r sin theta d theta 0 to pi. So this would be integral sine square theta d theta. I taught you how to integrate sine square theta in case you remember. Integral sine theta d theta. We did this in integration extensively. I told you sine square theta is one of the most common integration karke. In case you forgot, I'll go back. So listen, sine square integration. Integral sine square theta d theta 0 to pi. You write this thing as 1 minus cos 2 theta by 2. This would be half integral d theta minus integral cos 2 theta d theta. This would be pi minus half sine 2 theta, limits will go from 0 to pi. This would be pi minus half sine 2 pi minus sine 0. That would be, both would be 0. So you end up with pi by 2. Similarly, integral sine theta d theta, 0 to pi will be minus cos theta, 0 to pi. Cos 180 is minus 1, cos 0 is 1, this is 2. Substitute the values here. So this is r into pi by 2 by 2. Pi r by 4. That's your answer. Check. Sine square, cos square integration, don't forget. Very important. That is something which I mentioned while teaching you integration also. And this is how you integrate sine square in case you forgot. You have to write in the form of 1 plus cos 2 theta and 1 minus cos 2 theta and solve. Please check the steps. That's how you get the center of mass for even a non-uniform arc. So these are the two shapes. So next class when we catch up, we are going to do for a sector. Then we are going to do for hemisphere, solid sphere, different shapes. And then we'll go ahead. Okay. So with that, we'll wrap up for the day. So we'll catch up again on Friday, same time, 5:30. And the test is online until tomorrow night, 11 o'clock. So make sure to give. So any doubts, anything, please stay back and ask, or else you're free to leave. And we have done almost 8 questions so far. So please make sure to do this again, especially the integrations problems. Try to do them on your own. Okay? Sure. Any doubts you can ask me, or else you're free to leave.